Today's lesson will explain how stoichiometry can be used to predict the amount of reactants used up and products produced in electrochemical cells. In electrolytic cells, the amount of electricity used determines the amounts of substances that react and the amounts of the substances that are produced at electrodes. In the case of the zinc half reaction, 2 moles of electrons are used for every 1 mole of zinc atoms produced. Even though electrons are not exactly a chemical quantity, the coefficients can still be used to find mole ratios in stoichiometric calculations. Unfortunately, there is not a direct way to measure the number of electrons used. There is a way to figure out the amount indirectly, though. We can determine the charge in coulombs by multiplying the electric current in amperes by the time in seconds. This information does not give us the amount of electrons yet, though. Faraday was a scientist that figured out the relationship between electricity and electrochemical changes. He found that a certain amount of charge is transferred for every mole of electrons that flow in a cell. This amount is Faraday's constant. Faraday's constant is given to you in the data booklet, but the formulas you will need are not. The number of moles of electrons can be determined by dividing the charge by Faraday's constant. We can combine the formula for charge so that we can use the amount of current and the amount of time to calculate the number of moles of electrons. Here is an example that you might see where you will be asked to calculate the number of moles of electrons. You can use the values for the current in amperes, the time in seconds, and Faraday's constant to calculate the number of moles of electrons. Notice that the time given was in hours, and so it needed to be converted to seconds to perform the calculation. Since the mass of an element produced at an electrode depends on the amount of transferred electrons, a half reaction equation showing the number of electrons involved is necessary to do stoichiometric calculations. Concepts of stoichiometry used in other calculations can also apply to half-cell calculations. The only new part of the stoichiometry is the calculation of the amount of electrons based on the Faraday constant. Here is an example of a stoichiometry problem. You are given a current in amperes and a time in minutes. Copper is being deposited at a cathode, so you will need to use the copper half reaction. Underneath the half reaction, the known amounts are listed. Notice how the values that will allow you to calculate the moles of electrons are written underneath the electrons, just as we would usually write the mass and molar mass or the concentration and volume underneath our chemical amounts. Here we calculate the number of moles of electrons by using Faraday's constant. Now we need to use the mole ratio from the half reaction to determine the number of moles of copper produced. Finally, we can use the number of moles of copper, along with the molar mass of copper, to solve for the number of grams of copper produced. Please complete the October 31st quiz.